Hello everyone, I'm Suraj from Sri Venkateswara College of Engineering. Today we are going to discuss about SQL constraints and the retrieval techniques from the table which comes under database management system. First, starting with the SQL constraints. The constraints can be specified when the table is created with the create table statement or after the table is created with the alter table statement. The syntax for the SQL constraint is for the creating the table is create table, the table name it should be written, and in the brackets column 1 and the data type constraint that is used, then column 2 and the data type constraints, column 3 the data type constraints, and so on. The SQL constraints are used to specify rules for the data in the table. Constraints are used to limit the data type that can go into a table. This ensures the accuracy and reliability of the data in the table. If there is any violation between the constraint and the data action, the action is aborted. Constraints can be of two types, column level or a table level. In column level, it is used to apply for a particular column, and in table level, the constraint is applied to the whole table. The following constraints are the commonly used, for example, not null, unique, primary key, foreign key, check, default, and create index. Not null ensures that the column cannot have a null value, and unique ensures that all values in a column are different. Primary key is a combination of a not null and unique. Uniquely, it defines each row in a column. Foreign key prevents action that would destroy links between tables. Check ensures that value in a column satisfy a specific condition. Default sets a default value for a column if no value is specified. Create index used to create and retrieve data from the database in a very quick manner. First, coming to not null, we'll see each of them in detail. If we specify a field in a table to be not null, then the field will never accept null value. That is, if you will not be allowed to insert a new row in the table without specifying any value to this field. For example, below query creates a table student with the field ID and name as not null. That is, we are bound to specify values for these two fields every time we wish to insert a new row. The syntax for this is create table student ID int 6 not null. Here not null is used. Name varchar not null. Address varchar. Next is unique. This constraint helps to uniquely identify each row in a table. For a particular column, all the rows should have unique values. We can have more than one unique column in a table. For example, the below query creates a table student where the field ID is specified as unique, which tells that no two students can have the same ID. Unique constraints in detail. The syntax is given here. Create table student ID int 6 not null unique name varchar address varchar. Next is the primary key. As we already know that primary key identifies each row uniquely in a table. If a field name is set as primary key, then the field will not be able to contain null values as well as it should not have any unique values. So in other words, we can say that this is the combination of not null and unique constraints. A table can have only one field as primary key. Below query, create a table named student and specifies the field ID as primary key. The syntax is given below. Create table student ID int 6 not null unique name varchar address varchar primary key ID. Next is foreign key. Foreign key is a field in the table which uniquely identifies each row of another table. This is the field points to primary key of another table. This usually creates a kind of link between the two tables. Consider the two tables given below, which is orders and customer. Order has order ID, order number, and customer ID. Customer has customer ID, name, and address. As you can see clearly that the field in the customer ID in order table is the primary key in the customer table. That is, it uniquely identifies each row in the customer table. Therefore, it's a foreign key in the order table. Here is the syntax given. Create table orders, order ID int not null, order number int not null, customer ID int, primary key of order ID, foreign key of customer ID, references customers of customer ID. Next is check. Using the check constraint, we can specify a condition for a field which should be satisfied at the time of entering values for this field. For example, the below query creates a table student and specifies the condition for the field age as age should be greater than or equal to 18. That is, the user will not be allowed to enter any record in the table with age under 18. Now we'll see the syntax for this. Create table student, int id 6, not null, name varchar not null, age int not null, that should check age that is greater than or equal to 18. Next is the default constraint. This constraint is used to provide a default value for the fields. That is, if at the time of entering new records in the table, if the user does not specify any value for these fields, then the default value will be assigned to them. For example, the below query will create a table student and specify the default value for the age as 18. Create table student, id int 6 not null, name varchar not null, age int default 18. Next we'll see about the retrieval of SQL. In a distributed data system, a program often referred to as database backend runs constantly on a server, interpreting data files on the server as a standard relational database. Programs on client computers allow users to manipulate this data using tables, columns, rows, and fields. To do this, the client programs send SQL statements to the server. The server then processes these statements and returns results to the client program. The select statement is used in this. The select statement in SQL is used to retrieve or fetch data from a database. We can fetch either the entire table or according to some specified rules, the data returned is stored in a result table. This result table is also called the result set. With the select clause of a select command statement, we use to specify the column that we want to be displayed in a query result and optionally which column headings we prefer to see above the result table. The select clause or the first clause is one of the last clause of the select statement that of the database server evaluates. The reason for this is that before we determine what data to be included in the final result set, we need to know that all the possible columns that could be included in the final result set. Now here is a table given that consists of customer ID, customer name, last name, country, age and phone number. To fetch any column in the table, we use the following syntax. Select column 1, column 2 from table name, column 1, column 2, names of the field of the table and table name from where we want to apply the query. Select statements in SQL. To fetch the entire table or all the fields in the table, the syntax is given below. The table has customer name and the last name. So we select star from the table name. This statement is used to fetch the entire table. Asterisks represent all attributes of the table. Query to fetch fields customer name last name from the table customer. Select customer name last name from customer. To fetch all the fields from the table customer, select star from customer. This statement is used. So it will fetch all the fields from the table customer. Select statement by using where clause. Suppose we want to see all table values with specific condition, then where clause is used with the select statement. The query for this is select customer name from customer where age is equals to 21. Now next is the SQL select statement by using the group by clause. The query for this is select count item customer ID from orders group by order ID. Next is the select statement with order by clause in SQL. The query for this is given below. Select star from customer order by age desk. Thank you. I hope you understood all the topics that I've covered in this presentation and hope you liked it. Thank you.